What is up, ladies and gentlemen? Welcome to another episode of Math Made Easy, and today we're gonna be. Guys, I'm really sorry I didn't upload yesterday. It was a busy day for me, guys. But here we are back with Math Made Easy, guys. Please check out my gaming channel if you haven't already, and I'm gonna continue a very large number series because people haven't been giving me a lot of ideas for like theorems and stuff. Maybe doing triangle congruency theorems, SAS, that kind of stuff. Please comment down below. So the next logical choice for very large numbers. I mean, I know, a lot of people know about this one, but it's the Graham's number. Now, actually, not a lot of people know about it. We gotta spread awareness. But this is crazy, guys. So a guy named Ron Graham came up with this. And here he is, just in case you're curious. So, this, you thought they couldn't get any bigger. You really did think that, we couldn't really go on with this series. But no, guys. Humans cannot stop at the Googleplexian, a number which cannot even be written in this universe. We gotta go further. Come on. So here we go. So, first, I gotta familiarize you guys with something called arrow notation, okay? So, we're gonna have 3 arrow 3, let's just say. Actually, no. Let's do 2 arrow 2. So that's 2 to the 2. Which is 4. Pretty easy. What if we were to add another arrow into this? That would be 2 to the 2 to the 2. 2 to the 4. Would give us a 16. What if we were to add a third arrow? That would be 2 to the 16. Which would give us, please correct me if I'm wrong, but I reckon it is 65,336. Okay. So if that's 3 arrows, then let's put 4 arrows. Well, that's going to be a little bit hard. Because then we're going to have to take, if we were to put 4 arrows in between, we would take 2 and raise it to this number power, which, I don't know how many digits that would be. It would probably be 19 or 20,000 digits. So, yeah, guys, that's a couple killions, okay? I mean, it's big, guys. It's big, and I understand that for many people it is gonna be hard to grasp, but it's a hard thing. So now, undo all of this. So for Graham's number, we're not gonna use 2s. We're gonna use 3s. So 3 arrow 3. So 1 arrow. Oh, I'm just gonna forget about running the 3s. It's just gonna be 27. So, 2 arrows is going to be this. It's going to be this. So, 7 trillion. I'll just put 7t. Now we're going to take 3 raised to that 7t power for 3 arrows. So that's going to be about 3.6t digits. So that's 3 arrows, and we're going to take 4 arrows. So it is going to be about, geez guys, 4 arrows would be, it would be about half of this number of digits. So this number of digits, like, it's just incomprehensible, guys. So if this makes any sense, I'll just put this arrow times 4 equals this this big amount of digits, and that's about over 2, right? Because 3 to the 2 is 9, which is ballpark 10, right? So for this number, we're gonna do so this is not Graham's number yet. 4 is not Graham's number yet. So we're gonna have to take this number, 3 arrow 4, and that is the number of arrows that we put in our second layer. So let's just call this the first layer. This is the second layer. So it's this. So this is the amount of. So this, the first layer is the amount of arrows in the second layer. Okay. Third layer has the second layer amount of arrows in it. Fourth layer has this third layer amount of arrows in it, and we do that until we get to the 64th layer, and this is Graham's number. What does Graham's number represent, guys? So this is the 64th layer is Graham's number. Very incomprehensible, guys. I know, honestly, you know, I'm pretty good at maths, and it's hard for me too, guys. I would normally, you know, go on and start, you know, finding something and something and something in some parallel universes like I did in the last video. Way to compare this. But, really, guys, there is no words to speak for this number. It's just, you know, rather big. Okay, so I can't really compare this to anything, so let's just realize what it represents. It represents, so say we have a two-dimensional shape. We draw lines, and we have one be white and one be black. So it's obviously avoidable to have all of these lines be the same color. The same is avoidable in 3 dimensions, and in 4 dimensions, and in 5 dimensions. And in some number of dimensions between, we have proved, Graham has proved this mathematically, and he explains it in the video I'll link down below. Graham's number is the number of digits, not digits, is the number of dimensions that we know this kind of configuration where, like, say everything is black is definitely avoidable. I mean, definitely unavoidable. So this is not avoidable in Graham's number of dimensions. Aren't you happy we don't live in Graham's number of dimensions? I would be very confused right now. But we don't know. And ultimately, the number of dimensions could be as small as 13. So, I mean, why? This is practically an unsolvable problem. Why didn't Graham just tell everybody that it was 13? I mean, come on, guys. But it is some incomprehensible number of incomprehensible number of incomprehensible number of digits, I guess. Like, but something that really will humble you is that they get bigger. Imagine this. Next episode, they'll get really big. And I probably won't do the next episode tomorrow because honestly, these take a lot of research. Okay, they don't teach you these in math class, in my math class either. So I have to kind of do some research on this kind of stuff. So that'll probably be out Wednesday or Thursday. I'm also going to be having my state math practices pretty soon, and those are going to be an hour and a half drive away. So we're going to be very busy with homework and also that. So have a good day, guys. So just to recap, somewhere between 13 and Graham's number of dimensions, there is a number where this configuration, where everything is one color, on one of the planes is completely unavoidable. Let me know in the comments, what do you think it is? Have a nice day.